Today we'll go over the third part of rational functions. We will be doing full-blown graphs today, and one more shortcut to help you figure out about how the graph is looking. And the last shortcut we'll go over is intercepts, finding the x and y intercept, and it's really no different than what we have done in the past. So first of all, to find your y-intercept, you just simply, excuse me, I gotta sneeze. Whew, it left me again. You simply take the input, which is going to be your x value, and set it equal to 0. Okay, let's put a little x up there. And so if it's defined, it'll work. If it's not defined, then there's not a y-intercept. Okay, and so the x-intercepts going to be a little bit different. X-intercepts going to be what makes the output 0. Well, we're dealing with a rational function or a fraction. So in order for a fraction, let's just say a over b to equal 0, all I really need is for the top to equal 0. So whenever I'm looking for x-intercepts, they're going to occur when the numerator is equal to 0. Okay, so let's put this to work real quick, and then we'll use it in a graph. So I want us to find the intercepts of this very colorful equation. So I'm going to do the y-intercepts first. Y-intercepts. See, y-intercepts is going to be something, or 0 something, right? So plug in 0 for your input. Well, if I plug a 0 in here, here, and here, that's just going to leave me with -6 over -1, which is 6. So my y-intercept would be 0. Okay, for my x-intercepts. X-intercepts, it says, it wants to know it's actually, this is going to be 0 right here. So what happens is the whole thing has to be 0. But in order to make a fraction equal to 0, you just have to set the top equal to 0. So I do a little factoring. So x minus 3 equals 0, so x equals positive 3 and -2. So there's actually 2 of them. So it'll be the points 3, 0, and -2, 0. Okay, and that would be the only 2 spots that my graph touches the x-axis. I'm going to modify this a little bit. I've taught it a couple different ways, but I'm going to knock out step 5. Okay, and so to graph a rational function, you definitely can do step 5, but I'm going to try to teach it without, just because we spent so much time on it, and I think we have a good grasp on behavior of near zeros and around zeros. So first of all, I want to factor the numerator and denominator, okay, and hopefully get something to cancel out. If it cancels out, we know we get that removable discontinuity. Okay, if not, I'm ready to do exactly what I just did. Okay, locate the intercepts. Remember, the intercepts is going to come from this numerator, while the vertical asymptotes are going to come from the denominator. The whole point of doing step 1. Okay? Do step 5 if you need to. I'm going to try to teach around that, but I think we're going to be ready for a sketch based off what we have done so far this unit with graphing. So I want to graph this rational function. I can skip steps 1 and 2. Step 1, it already is factored. It doesn't factor any further, which means it's in lowest terms. So I'm ready to find my intercepts. So I'm going to go ahead and just make a little XY table here. That helps me in finding intercepts. So I know if I plug in 0 in for x, I just simply get -2 for y. So I like to see my points like that. So I'm going to come over here and I'm going to get the point 0, 2. And remember, to get my x-intercepts, I've got to take the top, whatever makes it equal to 0. Well, 2 is not equal to 0, right? 9. This thing's never going to touch the x-axis. This is all I have so far. All right, I'm ready to go to vertical asymptotes. VAS, remember that's just the bottom. So I get x equals 1. Horizontal asymptotes. In the last video, we said it was a competition between the top and the bottom of which one has the highest degree. Sure enough, the bottom has the highest degree at 1 with a degree of 1. And so the bottom wins. It's just my x-axis. And then from here, I just want to look and see if it looks like my reciprocal function or my reciprocal squared function. So remember, my reciprocal function, whenever I drew it, it had its branches. It had like one upstairs, one downstairs. I think that's a good way to think of it. Whereas if I had 1 over x squared, my branches, oops, let me undo all this. My branches were on the same side. They were both upstairs. Okay, so this one doesn't have any squared on the bottom, anything squared. And so, yeah, my branches are going to be 1 upstairs, 1 downstairs. I'm pretty sure this one's downstairs because of that point that I found earlier. And then 1 upstairs. A lot of students are asking me, hey, aren't you going to be picky about what point it goes through up there? Not once we've made it to this part, okay? If you need to plot a point, like it said in step 5 on the last screen, you can definitely plot a point up here and find its y coordinate, but that's going to be good for what we're doing in here. And let's step it way up to this one. Okay. So my first step is going to be to factor both the top and the bottom. I think if I do hold on, 3 and 2, so plus 3. Oops. I just changed this example. So I want to make sure I have the right one up there. Let's see. So plus 2 right here. There we go. And minus 3. Sorry about that. And then x minus 4 and x plus 1. I've got it factored. Now I'm really hoping something cancels on this because that will make my work so much lighter. Fortunately, this one does not. Okay? So I am ready to go to my x and y intercepts. So plug in my zeros. X-intercepts. If I plug in 0 for x, I think it's easier to plug in 0 for x up here. It just makes all these terms that have those x's in it cancel. I'm left with -6 over -4, which is 1.5. Right here. Okay. And then the whole reason of factoring this was, yeah, to see if something did cancel, but if not, I could add 3, divide by 2. I get 1.5 again for an x-intercept. That's just a fluke. Right? That doesn't happen very often. And then x plus 2 equals 0, so I get x equals -2. So there's actually, like we had in that first example, a couple of x-intercepts on this. So I've already got 3 points in my graph just from finding my intercepts. Hopefully I can make sense of my vertical asymptotes. So we're just bringing these down. It's going to be x equals 4, x equals -1, because that's what makes my denominator equal to 0. So 1, 2, 3, 4. There's going to be an imaginary vertical line over here. And x equals -1. Ooh, kind of split through these points. That'll work. I do believe on the last example, I did leave off that horizontal asymptote. I apologize for that. I might go back and remake this video. But if not, the bottom did win on that horizontal asymptote. Okay, so if the bottom does win, it means that there is a horizontal asymptote at 0. Okay, on this one, the horizontal asymptote, we got a competition going between the top and the bottom. Oh, we got a tie on this one. So we are going to turn to a ratio of leading coefficients, which is 2 over 1. Turns out to be 2. Okay. Now I'll tell you, on the outside, we're still going to have those branches that we had, like we have up here with the 1 over x. Okay. So the fact that I have a dot right there, I know I'm going to approach these isotopes, and it's going to look something like so. Let's look at this middle right here. I want to make sense of what we already know. Okay, if I need to, I can come over here and I can expand this table on down and plot in as many points as I need to. But I'm going to tell you guys, it's going to get tedious doing that with these rational functions. Instead, what I'm going to do is I'm going to find where this 1.5 came from. This 1.5 came from right here, this 3 halves. I look at this 3 halves, it came from this factor, 2x minus 3, which was to the first power. Guys, this goes back to my same rules I had for polynomial functions and their zeros. If this has an odd multiplicity right there on top, it will follow and it will have an odd multiplicity and go through the x-axis and come down. Okay, if this was a 2, 2x minus 3 to the second power, just suppose then yes, it would have just bounced off and created a U in between my isotopes, but it wasn't. It was a 1 up there. Finally, if you need to, plug 5 in right here, and you can definitely see where that is going to be. However, I'm looking at the bottoms down here, and these are all to the first power as well. So they're going to behave like my 1 over x right here, which was to the first power. So that means if I have a graph that is going downstairs right here on this side of the isotope, I'm going to come back and this part of the graph is going to be upstairs, just on the opposite side. Another way to think about it is, okay, x minus 4, that was my vertical isotope. It has a multiplicity of 1, all right? And so if it has a multiplicity of 1, on one side of the isotope it's going to be downstairs, then the other side is going to be upstairs. It crosses the x-axis, all right, same as it did with a multiplicity on a 0. And guys, this would be full credit on your graph. I don't want to in any way make that sound like that was an easy graph. That is not an easy graph. But if you can find your zeros, you can locate your isotopes, and you can kind of relate what we did back with polynomial functions. It isn't very bad to work these. All right, lastly, again, I want to get this thing in factory form. I'm going quickly because I do want to work a couple more of these the other way. So if I'm going too fast, please pause the video and catch up. Now, before I get going on this one, okay, it's looking like it's going to be very similar to the last one. However, I assure you it's going to be easier as long as you see that we have a removable discontinuity. X minus 2, I have that in common on both top and bottom, leaving me with a much simpler equation. Okay? Now, I do want to go ahead and take care of this removable discontinuity. All right? So I crossed out x minus 2. And so I want to go ahead and plot that removable discontinuity. So I plug 2 in for both of these x's, and it looks like that gives me 3/5. So there's going to be a hole in my graph at 2 3/5. I don't have much room there, so I'm just going to make a giant hole right there. Now, what I can do is I can be done with this. Right? I don't even have to worry about it anymore. I can work with this reduced equation right here the rest of the time since I have that hole plotted. So it's factored, it's been reduced. I'm ready to find my intercepts. Okay, 0 and 0. So if I plug in a 0 in for x, it gets pretty easy to see that I get 1/3 for my y. 0, 1/3, right here. And remember that my x-intercepts come off the top. X equals -1. So here, well, those are lining up kind of nice. Looks like I'm going to have a va. Let's see, there's going to be a va at x equals -3. So I'm over here, 1, 2, 3, and an imaginary dotted line going down. My ha on this one, my ha, there is a tie. So again, I'm going to go with a ratio of leading coefficients, 1/1. So that would just be 1. So it's very easy to see what one of these branches is doing, right? Now again, I'm looking at this. I don't have anything squared. If this was x plus 3 squared, then they would both these branches would be down underneath this isotope. But since it's x plus 3 to the first power, it's going to act like my reciprocal function, where 1 was upstairs and 1 was downstairs, and that's going to be my answer on this. Let's skip this one. I want to try these in reverse. Trying these in reverse I'm doing a lot of the same stuff I did whenever I worked it forwards. I'm still going to find my x-intercepts from their numerator, okay? So x-intercepts come from the numerator. Make sure you check for their multiplicities, okay? And then from the denominator, same thing's going to come from the denominator, your vertical isotopes, okay? And also, it's like checking their multiplicity, but I'm going to check for their power, what they're being raised to. Is it acting like the reciprocal function, or is it acting like the reciprocal squared function? Okay, and then just as we've done this whole unit, we're going to be looking for that stretch factor. Okay, so I'm going to give you a graph, and you just have to tell me what an equation could be. So overall, what this is going to look like is y equals a times, and just put that stretch factor right in front of that fraction. And now I'll take care of any stretching that needs to happen. So first thing I look for is my numerator. Okay, what we just said was the numerator is what, where it crosses the x-axis, any x-intercepts I have. So it's going to be, there's 1 at 3, so it's x minus 3. And then x minus a negative 2, which would be x plus 2. And then whatever makes the bottom equal to 0, remember that's my vertical asymptotes. Vertical asymptotes there. And so there's 1 at 2, so I'm going to put x minus 2, x minus a positive 2. And then there's another one at negative 1, x plus, be x minus a negative 1, so x plus 1. Now I haven't messed with the multiplicities or anything yet, so let's go back to this 3 right here. Okay, this 3 it crossed the x-axis. I'm going to leave that to the first power. Okay, remember, if it crosses the x-axis, it's an odd number. It's an odd multiplicity, and 1 is the nicest odd number I can think of. Same thing happens at negative 2. Now look at this horizontal asymptote at 2 right here. Okay, at 2, this horizontal asymptote. Look, they're both going downstairs right here beside it, right? If they're both going downstairs like that, that's behaving like the reciprocal squared function. So on the 2, I want to put the reciprocal squared. Okay, just put a squared on it. Well, look at the positive, or look at the negative 1. I have 1 going downstairs, 1's going upstairs next to it. They're on opposite sides. Okay, so you can think of it across the x-axis, I guess. That's one way to think about it. But it is going to be odd. So again, I'll pick the nicest odd number I can think of. I just need to find a nice point now. And I'm going to choose a 0, negative 2. And then that should help me find that stretch factor. So I'm going to plug in that negative 2 in for y. I'm going to plug a 0 in for all these x's. I like plugging in 0. That's going to make the work go pretty quick. Okay. I still have this a right here in front I'm looking to solve for. This negative 2 comes down. I have an a. So negative 3 times 2 is negative 6. Negative 2 squared, that's positive 4. To get rid of a fraction, I'm going to multiply by its reciprocal. So multiply both sides by negative 4/6. See, that gives me negative 8 over 6, which is 4/3. My a is 4/3. I think in your book, they go ahead and multiply everything out. You do not. You can leave it in this factored form. Or you can multiply it out. I'll have it on there both ways. Okay. So this would be a correct answer.